Okay, now members, we are going to see projection from level ground. That is our case 2. So we have seen the horizontal projections when it's projected half when the initial velocity is horizontal. Now here, our particle is going to be from level ground. You project it from that ground. So consider the particle projected with velocity u, with u making an angle theta degrees with the horizontal. Now what is this angle projection? It's the angle made by the initial velocity with the horizontal. Now this is our horizontal on the ground. Okay, now as we saw, after a certain point, now this particle will have a new velocity, what we call v. So after when it leaves this point, it's going to reach this side as now a new velocity v. So when I do this square, it means that now we have new velocity, which we are going to resolve it into the x component and then the y component like that. So at this point P, as you're going to see there. So theta is the angle projection, r is the distance covered by the projectile from here up here covered by this particle. Then h is the maximum height attained by the particle. So initially I when it is 0 at this point here. Now at this point we only have this velocity here. When I solve this velocity now into the x component and then the y component of this. Now from there, I think you can see at this point O, we are here. At this point O, now using the 3D ratios, I have cos theta is equal to adjacent over hypotenuse cross multiplying make ux. I get now at this time, ix is going to be the horizontal component there. Then sin theta is going to be opposite over hypotenuse. When I cross multiply, I have this. So that's the y component. I mean this velocity component vertical there. So, but now this was initially a time. That's why we are resolving now this force u. Okay, this velocity u into the x component and the y component. Now, after time t means that whenever there's some time that has elapsed, now our velocity is going to change. So now there we have velocity v. This particle will pass through a point px with a new velocity v meters per second. Now, if you have v, we also resolve it into the x component and also the y component as you saw. Now, at this point, this one is going to be our x and then this one is going to be our y, the vertical component there. Here it said it was at 0.00, so there. Now, what is the horizontal motion? Remember the first equation of motion, v equal to q plus at. Now, we are now moving horizontally, so vx in our horizontal motion is going to be ux. But remember, if we are moving on the horizontal motion, acceleration there is 0, because horizontal means you are not changing the velocity. And if there is no change in velocity, then there is no change, there is no acceleration. That's why you say our acceleration is 0. Okay, so there, then we see our vx will be equal to that. But what is our ux? Our ux is this, then we put it there. Then when we come to the distance, our s, of course, is given by that, the second equation of motion. Then our distance, horizontal distance, we have this plus this. Of course, when we have horizontal distance, acceleration is 0, and so ux, substituting there our ux, then times t. This is times t. So the whole of this t is multiplying that thing. Then what happens if we have a vertical motion? Now, in the vertical motion, if we have this first equation, we are going to be having vy, then vuy, then in the vertical motion, our u is going to 0. No. Our u is going to 0. Our u here is going to be our u. Why is our u not 0? The idea is very easy. Because here, the particle at this point is having an initial velocity. So that's why we are not taking our u to be 0. But the other side, from horizontal projection, it was coming. It was just dropping. That's why it was 0. But here, this particle is having a certain velocity, which is uy. So that's why from here now, we substitute our uy plus. Now here, this acceleration, because the body, you see, vertical, our body here is going to be going up. This time it's not falling, so it's going up. So it's that it's acting against the gravity. That's why we have a negative V. Because our body, see, the body is going up. So that's why we have our V as negative, because it's acting against gravity. So putting our solution there, this is what we get the vertical component. And then getting the distance, our SY, putting in here, but at this SY, the distance covered by the particle from here up to here. This is the distance covered by that particle as it's moving, which is Y. That's why we have Y there, and it's going to be according to that. Now, at maximum height A, at this height A, we say the moment it's maximum height, there before you turn, maximum height means that's the level, that's the highest you can go. From there, then you will fall. Look at this, when this thing is coming from this height, it's going to come, which is maximum height. Now at this height, before it turns to fall, there we say that velocity is 0. So there the velocity Vy is going to be 0 when standing. So it's going to come, then after time, there is that height it reaches, then it falls. So at that height there, our velocity is already 0. So that's why when this Vy, when this particle now reaches this point, at this point here, our Vy is always 0. So that's why we have it like that. And then if Vy is 0, we put it here, we make to the sign that we want to know how we get the time at the maximum height. What time does this take that particle to reach the maximum height? This is the formula for reaching the maximum height. Taking this sign and then divide through by d to make the something, and that will be the time. The speed and acceleration and direction of the particle after time t. So after time t, this is what we need the speed. Just get the square root of this squared plus this squared. Then the direction, we just get alpha tan inverse of Vy over Vx. As simple as that. So for now, that's the basic of the projections from level ground. Now we are going to see the next lesson. How do we get equations of the trajectory, this maximum and so on. Don't forget to subscribe to the channel. Wish you well.